Okay, 3 o'clock, time to start. Hello and welcome everybody to a new webinar here from FLUXANA inside XRF. Today's topic is the practical use of cups and films. It's kind of a repeated study. We did a similar one a few years back, but we do want to come back to it. So let's get right into it. As always, if you have any questions, feel free to write them in the Q&A section. We'll see if we have some time to answer it later. Otherwise, we'll get back to you by email. So yeah, if there's anything crossing your mind, just write a quick message in the chat. So when it comes to analyzing liquids and powders, we have to select a sample cup and a film in order to get like the best results we want. So why is this? Okay, so the context of our presentation today is we'll talk about the theory of measurement of the liquids and powders. We'll talk about the sample cups and the films that are used for those. And we'll try to give you a general idea of how to handle this in terms of the task to analyze the samples. So when it comes to you've probably seen this one before in one of our presentations. Today we'll be talking about the analysis of loose powders in the powder form, not the pressed pellet, and also the analysis of liquid samples, be that fuels or oil samples or water-based samples, anything that comes as a liquid. So the general idea is, in order to measure them, we need to put them into some sort of cup. And these cups, or sample cups, how we call them in English, are basically assembled from components, and the base of the cup is a thin film that is transparent to X-ray. This, of course, the presentation is mostly or almost 100% about measuring samples from below. There are X-ray setups that measure from above, and there is some tricks to actually use sample cups with those as well. But for our presentation, we'll focus about the general setup where we have the X-ray tube below our sample, and the sample itself will be the sample cup then filled with the liquid for analysis or the loose powder. One important thing to kind of remind you about or to talk about is when measuring liquids or powders, you should always do this in helium and air. Vacuum as an environment is not allowed, even with the powder samples. Obviously, vacuums and liquids will just evaporate and you have it all inside your machine. You could do a loose powder in vacuum, but we don't recommend it. It's always best to treat loose powders, especially fine ones, as liquids so you should always have a protective atmosphere. And well, air works, but helium works better. Just keep in mind, don't use vacuum even with light powders. That will just be a mess. The first question that always comes at this point is, which cup do I need? And it pretty much depends on the model of your X-ray spectrometer. For different spectrometers, there are different cups available, and we'll go over the kind of cups, the type of cups in the next foils. If the cup comes with a lid, we also recommend to always use this as it protects the entire thing. The lid is optional. You can just leave it out, but the way the measurement works, we recommend having it because it makes handling it easier, handling the entire cup. The first news about sample cup is quite a pleasant one for FLUXANA as a company, because we are now producing our own sample cups. The cups in general always follow these kind of principles, that you have an inner ring an outer ring, you have your thin film in beneath, and you press it together to form this cup where you then pour the liquid or powder. And then you have a lid on top, or maybe even a second film on top to kind of enclose the whole thing. And FLUXANA has been designing these cups or kind of redesigning in. So we have our owns now, and they follow like these very easy formula that you always have sample cups, and then you have lid, you have inner ring, you have outer ring, and you have the thin film. And they are available for every spectrometer, basically. The clue about them is that we have kind of refined the production, and we think that it is a lot more environment friendly now. We have to think about the sample cups. This is all a lot of plastic, and it is disposable. So the way these things were used to produce is with a so-called cold runner technique, where we would have the molten plastic inserted into, yeah, a cold casting dish, which in the end would always lead these excess materials or canals, and we would need extra plastic or molten material to produce them. You might be familiar with these ones that come with these little, there's one model that has the three things in one. So they come as the like um, these setup. You have the inner ring, the outer ring, and the lid, and then there is this canal that connects them, and you would always have to cut them off. So in terms of work, that was also not easy to handle. And generally speaking, this older technique produces more waste, which we wanted to avoid going into the future. Sustainability and environmental friendliness is always a topic to kind of follow, and in laboratory reducing waste was the goal here. So what we ended up with is doing the so-called hot runner technique. So what we inject into our casting is actually molten material. We don't heat it up in the process. It comes in directly. And so we can produce each piece of the sample cup individually without having the canal or the runner. This technique is also more precise, and yeah, like I said, we can do each part individually. And the reason this lid is important, we'll come to in the next. I think it's already the next thing. Yeah, if we summarize this, the FLUXANA cups are more sustainable because we can do each of the three parts individually, and you can also buy them separately. They don't come as a bundle; they come as these three separate units, and especially when it comes to the lid, I mentioned before, we recommend using them, but in practice, we know that a lot of customers do not. They end up buying a package of 100, 100, and 100, and they never use the lid. So this is all just going to waste. With our setup, you can buy them individually. The lids themselves, they have ventilation holes for pressure adjustment, which can also be used for auto samplers. So the whole thing is also designed a bit smaller, especially, well, for the one that we use, which is the 40 millimeter, we designed the outer ring to be a bit thinner, again, saving material. So the whole thing gets cheaper since you can buy them individually and we use less material to produce them. So yeah, we save around 20% of the material, as somebody came up with that. And when it comes to the naming, yeah, well, this is basically an overview of the samples we have now. So you can see for all the different manufacturers of the spectrometers, we have a similar one, and it is very easy to combine these parts to what you need. For example, we used to use the 33 40T or 40 for all of our machines. This one is just a bit higher than the other one. The diameter and so on are the same. With the new setting, this is all just the same part, basically. So we have the inner ring, the outer ring, and the lid. And yeah, you have the diameters here. You can see this one is just like the height is different now. That's why it's different numbers. So in the end, it fits into a different cassette on your spectrometer. But yeah, you can combine things with the same diameter and just find what you need for your spectrometer then. Yeah, so we have the new cups. We are quite happy with those. Also, they have the lid in nice FLUXANA blue, so that's always a plus. Let's talk about the films, which is a more complex topic relevant for the analytics now. So the cups here, basically, these are decided by the cassette you're using in your spectrometer or the position on your autosampler. The the film you will use, this will be more a question of what kind of analytics do you want to run. So these films come in different materials, different thicknesses and different shapes. We have a few examples here. So we have the small cup here, a larger cutout, then we have a square cutout, and then we have this whole thing on a roll. So what is important about the film? When you go to an application, when you want to make a liquid analysis, the thing you do first is you choose the right film material for your application. You can group them up. There is mylar, which is a polyester. There is polypropylene, which is polypropylene. Then we have Captain and Petriox. These are kind of special ones. The Petriox also is the same. Is also a polyester, same as the mylar. It comes in a different thickness and it has some other qualities because the production is a bit different. But basically, you have these 4 groups of materials, and as you can see from the description, the mylar is very good for petrol and diesel, but is not suitable for acid and bases. There will be like a incompatibility. It will attack them chemically, while the polypropylene is the other way around. There is a lot of samples where you can use both, and in the end, you should always test your compatibility with the sample before doing the measurement. And so, yeah, for each of them, there is known applications, and you can kind of look for them for guidance, or you can just test it by filling it up and leaving it overnight and looking the next day if it's still stable. So yeah, the thickness, these are the ones that are available for the FLUXANA film. So you can see from thin to thick. We'll come to the importance of the thickness later, but you can see that certain thicknesses, like they're not all of them are available for each film. So the mylar comes in 2.5 and then 3.5, and then I think it's 6 exactly. And the polypropylene already starts at 4, and then there is the 6 one. So there is an overlap here, but yeah, different thicknesses for different films. And yeah, the shape, depending basically on the diameter you want to do. There is the roll, which is always the easiest. You just have to cut yourself. It's a bit more labor intensive, let's say. And these pre-cut circles, they come in different diameters, matching your cassette or the diameter of your sample cup. Obviously, if your circle is 41, then having a 41 cassette makes it difficult. So you always have to have a certain overlap so it fits together. Yeah, and the more interesting questions for the analysts is, what do I want to measure in my liquid or powder? So we have to be aware that the film we introduce into our measurement setup is absorbing X-rays. Going in doesn't matter that much, but going out to the detector, the fluorescence we are measuring, this is quite important. So if we're looking at the transparency of the films, we can see a comparison here. We have compared the light elements mostly here. Sodium is the first one that is affected, and it's the one that is affected the most. Everything lighter than sodium is very different to measure with a film. I would even say impossible in practicality, because just the film absorbs all the X-ray fluorescence. There is just no signal left to evaluate. So sodium is the first one we can measure. And then if this is important for you, of course, you want to go for a thin film, for example, to have the maximum transparency, the maximum transition. And the interesting thing now is the materials have different properties here. You can see that the lightest film available, we're not selling it, but it is available, is a Mylar 1.5. This is the lightest one. So we set it as at 100%, and then you can see how the other films behave. As this is a relative table, we'll have a look at an actual scan. So this is a solid sample we took here to actually be able to measure it without a film. And yeah, we measure, the black line is basically the scan on, this is sodium, the lightest one. So that is our signal unmodified by a film. And now here are a few examples. The polypropylene FEAR cuts it by half almost. Then the Mylar 2.5 and the polypropylene 6 are very similar in their absorption. That's why these are basically our preferred one. And then if we look at the thick one, the Captain, it almost kills the entire signal. This is for sodium. A similar example is here for sulfur being a element of higher order in the periodic table, so a more heavy element. You can see the effect is still the same, but it's not as profound, let's say. The effect is lessened because we are using stronger X-ray fluorescence that just are not that easily absorbed by the film. So still we see the effect. The order has also remained the same, but the effect in general is not that strong. So yeah, the thickness and the material are very important choices when it comes to the task you want to analyze. When choosing what analyte you want to analyze and what metrics, it's important to think about what is possible. And generally speaking, you want to go for a thin film in order to go for the lighter elements. If you go for heavier, it's more about going thick so that you have a mechanical stability and you don't run the risk of, or less risk of breaking during the measurement. When speaking about analyze, we also have to speak about what kind of impurities do we get when introducing the film. This is a test that we made on a blank oil. We have a method where we control liquid sample, and we're using a pure synthetic oil to kind of evaluate the zero level of intensity. So we just took the blank oil and we measure it, and when we do it in the correct way, we get zero, basically, a plus a few ppms per element. When we're now using the same approach with these different films, we get a blank result. So when it comes to impurities, the Petriox, remind this is the same polyester material as Mylar, just a different thickness. It actually has phosphor and silica in then, and silica in quite a large amount, while the Mylar always has calcium and phosphor. This is due to the way it is produced. This is something with the catalyzer used in the production. So even though they're chemically the same material, there is other different impurities in there. And as you can see, the polypropylene is pretty clean, but Mylar and Petriox and also Captain have some impurities in there. And you have to keep that in mind when designing your analytics. Also, when you're changing the batch of your film on a given application, it's always a good idea to check if they changed. In our experience, it doesn't change much, but just always better to be safe. When you change the batch of your film, just check if the control sample is still the same. Yeah, in the end, you then combine all these into your setup, basically. And yeah, we have a few examples here about what is used. I mentioned before we didn't use the thin Mylar here because this one was performed on a wavelength dispersive unit, and we don't use the thin films. There you see the very thin ones, the 2.5, we use on our energy dispersive system. And the thinnest one we use on Our wavelength dispersive unit is the 3.5 miler, and then all the other ones follow. The 3-point, the Petriox is also fine. So there is a few examples on here that we use in the laboratory. And yeah, feel free to come back with questions about that. So the final thing that we have, well, we always had that at a product buyer. We have our cups now. We also have prepared cups for customers who don't want to do the assembly themselves. There is various combinations, not going to go through that list, but basically what you can do if you want to do a certain analytics, you select your cup, you just select your film, and then you just combine this as a number, and we'll assemble them for you. And you get like these little trays full of prepared cups ready to be used. I touched on this already a bit, well, briefly, about the thickness. There is certain effects on the materials. So for example, we like the polypropylene because it works for most of our applications, and the 4 micrometer thick one has almost the same transmission as the 2.5 micrometer of the Mylar. So we prefer the thickness, the thicker film for mechanical stability and more easy use and handling. But the problem with this one is the polypropylene, it shows a sort of interaction with high power X-ray radiation. So the longer you measure, it kind of starts sagging or deforming. So this is something to keep in mind when you are measuring liquids and loose powders. You don't want to measure the sample or the sample cup for a too long period. A good time frame is 10 to 15 minutes. That's usually what most application programs designed for these samples run about. So if you're looking at, for example, oil analyzers, it's usually like 12 minutes or something. And the reason is just you don't want to overdo it with the exposure in order to, again, prevent breakage. There is a neat thing you can introduce a primary beam filter. Usually the aluminum one is used to kind of minimize this effect. So for some channels in the setup, it makes sense to do this in the measurement program so that you kind of ease the stress on the film. Measurements with lower power, lower than 1 kV basically, or kilowatt it is, sorry, and energy dispersive methods which also fall in that. They don't usually show this effect, and the Mylar also does not show this effect. But we'll come to that in a later thing. I always want to kind of stress and repeat the golden mantra of liquid measurements: don't measure a cup twice. You can reuse the cup, but then give it a new film, because the film does not get better over time. And what you want to avoid is breakage during the measurement in your machine. That will be a big mess. So handling the analytical performance, or in this the error, depends on the cup here. We have to make sure that the cup is kind of prepared in the same way. So you do want to make sure that you always fit it correctly and avoid like these little things or these things. We recommend using a little tool. I think that comes later. It actually is here, yeah. We always like using this little extra tool here, which you just put on top. There is a little picture instruction here. So we start with the inner ring, facing upwards in this case. The inner rings of our films, they don't have an orientation, so it doesn't matter which side you pick to put the film on. But for measurement purpose, this will be the bottom afterwards. So we prepare it dilates and then we turn it around. There are other models that have some sort of ledge or edge where you have an orientation. Ours do not. So again, it's more universal, let's say. But yeah, we turn it upside down. We put the film on top, and then we gently put the outer ring kind of with the hand, and then we use the tool. The idea of the tool is that you can press it downwards and you avoid this here because it will stop you. You also avoid the overpressing and you avoid tilting the whole thing. If you then want to use a lid that would go on top after you have filled the sample, of course, you could also use a second film on top for special applications. I mentioned before some people measure from above. That would be a reason, but there might also be other application that kind of want you to close the assembly basically with a second film, so no spillage and so on. In our case, we would also do we would always do the lid as the last one, mainly also because that allows us to label it and prevents mixing afterwards. But that is your general go about. As I said, always we recommend to always use the tool for assembling them to make sure it's always the same, and that gives us the best repeatability and the best accuracy in the end. Another point of discussion that we had a lot of customers ask us is how much sample do we actually use? And there is some examples coming up for testing, but what we need to talk about is that depending on your setup, there is a measurement geometry in this. So you see the usual setup when measuring from below is like this. You have the X-ray tube here, you do the irradiation, the whole sample gets radiated, and then we use the fluorescence that comes out for our analysis of concentration. So since liquids, this is more about liquids now, less about powders, but the rule in the end applies the same way. For liquids, we have to be aware that for different elements, we will have a different analysis height because of the geometry. Also, the opening in your cassette plays a role. So without going into further detail, we have to be aware that there is an effect, and that is specific for each analyte. It will be different for sodium than it would be for sulfur, for example. And the rule we always stress out is we do want to have enough sample, and then we want to do it constant. So what does that mean in practice? We have an example here of a recent test. What we did here is we used our SC11, which is the 40 millimeter, which is nice for our machine. And this was prepared with the polypropylene 60. And now we did an oil measurement. As I said, this is a standard method. And what we did is we filled a sample cup with 9 grams of an oil and then with 8 grams. So we doubled the amount. And looking at a few analyzers here, we do have sodium and magnesium on the left, representing the light energies, and then we have lead and molybdenum as the heavier ones. And the interesting thing is that when we fill more sample, we find less of the light elements and more of the rather heavy ones. So there are effects here that we need to, consider. And again, we don't want to go too much into detail, also because still have 2 minutes, so we're still on time. But yeah, the rule that it comes down to is you do want to have enough sample. In our case, actually, for molybdenum, for the high energy, we don't really quite have the correct filling height of our sample. We could do with more, but we did a calibration on 4 grams, so we can't change it. We can't change it. We have to kind of live with it, and it actually works with the 4 grams. But yeah, we want to have enough sample, and then you just want to have it constant. So the way it works is to have the okay quantity and then just stick with it. And that will give you the best results in the end. And the total amount now depends on your diameter, how much sample you have available, and so on. But yeah, you want to test it once, say this is okay, and then just stick with it and don't change it, because changing it can have some influences on your sample. So just to sort of finalize, when measuring, again, this is more for liquids, but some also apply for powders. So when you go about measuring these with cups, you first want to homogenize your sample. Heating up might be necessary for very sticky, oily samples. Some of them just are so, yeah, sticky that heating them up makes them flow more easily, and that helps with filling the cup. You fill the cup, you check for leaks. You should always do a long time term with samples you don't know. Leave them overnight, check the next morning if there is a leakage. If not, you're okay. And then before measurement, we recommend a short term test. Leave them on a piece of paper for a minute or two to make sure that there is no like problem in the assembly of the cup that leads to a leak. You do the measurement in helium and air. You get the sample out. Most machines have an automatic evacuation so that they don't stay in the spectrometer if it's a liquid measurement. And then you dispose of the sample. Now, some people just say, I want to remeasure it. So when you want to do that, we have it written here, never measure a cup twice. That refers mostly to the film. We set the reasons why. The film is not really stable. So if you want to do a measurement of a sample, or you don't have enough sample to measure two of them, what you can do is have two cups and fill one cup into the other. But don't measure the same prepared sample cup twice. At least replace the film in order to make sure your spectrometer is safe. And yeah, summary, in order to successfully and the best accuracy measure your liquids in porter, you need the cup and film and the procedure, amount, and so on. And yeah, if you want to have some more help with setting up, there were some examples mentioned, but yeah, get in touch with that. We can always help you make the decision depending on your spectrometer, the sample, the analytes you want to do. That's it. Thanks for your attention. Oh, I'm actually on time. So I actually don't see the question and answers now. So we will come back to you if there are any questions. We will come back to you by email in the next few days. Thank you very much for your attention and have a nice day. See you next time. Bye-bye.